In this video, we'll be talking about logical functions. So in the last video, we talked about what are some of the most critical functions that you need to know that are commonly used in Excel work papers. What we'll be talking about in this video is logical functions. So the difference between the two is a logical function is a type of formula which is used as a framework. So there's a few different functions in here which we're going to be talking about. The if function, which we mentioned briefly in the last chapter, the if error, the true and false, the and, the or, and the not functions. So what these are rules and frameworks which you can create more complicated Excel spreadsheets with. And how it works is, if we refer back to the if formula as our first example, is it has three components. The first thing is your logical test. And even in Excel, if you open up, it says logical test. The second component is an output if value is true, and the third component is the output if the value is false. So if you think about it, it's kind of like this. Here's your logical function. Here it's basically a question, and if the answer to that is true, you can set Excel down a certain path, and if the value is false, you can set Excel down a separate path. And what you can do is you can also kind of nest them like this and create multiple different paths like so, and eventually you can have a very complicated Excel structure in the background. So you can do all kinds of things. You can filter out, bananas from your apples. You can figure out your numbers over 1,000 from your data set, and you can figure out repeat numbers from your non-repeat numbers and all kinds of things. So if you want to filter a needle from a haystack, you can do that with these logical functions. Refresh with the if function, but in particular the nesting function. Quickly recap, we had an example where Alan, Bob and Carol are our salesmen, and we want to verify whether or not they've achieved their sales targets. So the question that we're going to ask here is their sales, in this little triangle here, is their sales greater than their sale target? Now we're going to move through this into one of two options. If their sales is greater than the target, you're going to go up this option, the value of true, and we're going to show a text if they've beaten that. However, if they haven't beaten their sales target, they're going to show a text of. So we can do that in our formula. So it's split into three parts. Number one is our logical test. Is our sales greater than our target? Then we put our output in text if the value is true, separated by a comma. Then put in text achieved. Don't forget the little apostrophe signs over there. And then if false, we type the text not achieved. Okay, and in the last video, we also discussed on a high level what nesting is. So we discussed about how we can have one of these on top of another one. So it doesn't have to be this if function, it could be something else like an and. But in either situation, this is the logical function here. Over here, we've got a situation where we want to give a discount if the product sold is on special offer, number one, and number two, if the order value is $1,000 or above. What we want our logical function here to be is number one, as a first rule, product on special offer, and number two is sales order greater than 1,000. Now if both of those are true, and the important distinction is that both of them are true, not one or the other, or neither are true, then if the answer is true, what we want to say is calculate a value of X amount for the discount value. So it's going to be a positive value for the discount. And if the value is false, i.e. if it's only one or the other or neither, then what we want is a value of 0, i.e. no discount. So the way we put that in a function is using the AND function, which we'll talk about shortly in how this works. So we'll include an AND function as our main logic gate. So let's have a look at the formula here. So we can see let's go to our if function first. So our logical test is and if both of those are true. If that's true, then we want to go D58, which is our order value times 10%. So it's a 10% discount. If it's false, then it's a 0, and the total is just the order value less the discount. Now, we'll talk about how the AND function works and some other logic gates which we can use. So here we have the AND function, and we talked about the previous example where we wanted to know in our logic function that both of two questions or statements were true at the same time. So for example, on sale and greater than $1,000. So how this function works is we want to test if Alan has passed all of his subjects. A pass is someone who's had a score greater than the average. So let's just test what this should look like if we take it individually. So is that greater than this number? True, true, true. Okay, so I've just dragged this across, and it's true for Alan that all of his subjects are greater than the average. So he's passed all his subjects. But how do we do that in one formula? I mean, I guess we could just drag it down for all of them like this. But then what we can't do is just use that into another if function. So let's just say what I want to do as my end result is to say if Alan has passed all of his subjects, I want Alan to get a special prize. And if he hasn't passed all of his subject, he won't get a special prize. So this is why we need to nest an AND function in an if function. Because what we want to say is if, I'm going to write this in English so we can make this make sense first. So if Alan has passed all subjects, value if true, I put a comma there, special prize, let's say we're paying out $100, and if not, he gets nothing. Okay, so I've just written that in English so it makes sense, but let's actually put a proper formula in there, because if I press enter, this isn't going to work. See? Okay, so what we want to do is, first of all, as our first stage, is get an AND function working, so we can then use that in an if formula. Okay, so this is why we can't do this. So the AND function works like so. Equals AND, bracket, and then all you do is you put in your logical functions separated by a comma. So the first thing I want to do is that greater than this row here, and I'm going to lock the 41. Yep. Now the next thing is English greater than this one here. Okay, so I'm just going to lock that again. I'm going to lock the row, and the final logic that I'm going to be using is that greater than that. Okay, now you just end it like that, and now you've got three separate functions which are split by the commas. Press enter, and the answer is true. Okay, so you can actually drag that down as so, and you can see that where there's a false, it means that not all of those criteria are correct. So you could have 2 out of 3 pass, and it'll show false. You could have 1 out of 3 pass, it'll show false. You could have 0 out of 3 pass, and it'll show false. The only instance where you're going to have a true answer is if all 3 of them are greater than, or are true, basically. And that's what the AND function is. So the alternative is if you only want 1 of the 3, or 2 of the 3, or any of them, you could use the OR function. So if I replace AND with OR, see how it's the same format now? It's saying logical 1, logical 2, logical 3. Except the only difference is you only need any of them to be true. Okay? Now we could also say the NOT function. What function does is it turns whatever value is in here to the opposite. So for example, if it says true here, then it's false. If it's false here, then it turns it to true. So what you do with not is if we want to, so we've got an OR function here. So if we want to know, so right now we're testing if any of them are greater than the average. What if we want to know if any of them are not greater than the average? Okay, what we would do is we just add a not function before this. And to be honest, I don't use this too often, but it's a good formula to have in your deck. So now what we're saying is these two down the bottom are the only circumstance where none of the scores are greater than the average. And the reason is the alternative is or, so it means that at least one of these, if an or function is true, is at least one of these is greater than the average. If it's a not function, it means that none of them can be greater than the average. Okay? What if we changed the or to an and? What are the scenarios that this is going to generate? Well, either a neither, as in no one has passed, or it could be or passed. So the only ones that are going to be false are the ones that have passed in all three subjects, because then that would satisfy an and criteria. So let's test this one as well. That's the only other false, and you can see that in those three situations, they received marks greater than the average. Okay, so I'm getting off topic a little bit. I just wanted to run you through some different ways of using a logic formula. Let's go back to our original task, which was if they've passed, let's say if they're passed in all of their subjects, we're going to give them a special prize. So we know what the and function is now. And let's just quickly recreate it. So if and greater than that greater than that, and that greater than that. So it's true. Then we're going to go if this logic test is true, then we want to put, let's put a prize of $100, and if false, then put a value of 0. Okay, so now let's drag this down, and this will sum us. If we sum this will give us the sum of the total prizes that we need to pay out. Now we can do a quick Alt equals on our keyboard, and then there's our total. So from a logical / visual perspective, this is what it looks like over here now. We're asking the question, if the student has passed all of their subjects, if the answer is true, give them a $100 prize, and if the answer is false, give them a $0 prize. What if we want to change this up a little bit, and we want to do an example where, okay, so first check if they've passed all of their subjects, then they get a $100 prize, but we also want to offer a $30 prize if they pass any of their subjects. Okay? But what we don't want to do is pick up on anyone who's received the $100 prize already. Okay? So you can't get $130. You get $100, and if you pass 2 subjects, you get the $30. If you pass 1 subject, you get $30. Okay? So how would we do this? Well, we'd have to use the negative arm of our nested function, and what we're going to do is we're going to nest another function in here. So it's going to look something like. So what we're going to do is, instead of putting a 0 here in the negative arm, we're going to do another if function. And it's going to be if any subject has passed, and then the outcome of that is going to be true, $30, and false, $0. Okay, so how are we going to do this? Let's have a look at the formula currently. So we can see that we've got, it can be a little bit tricky to read, but we can see that we've got an if function over here. The value if true is 100, the value if false is 0. So what we're going to do is we're going to delete out the 0, and we're going to type in a new function. So we're going to go if, and this time we're going to go use the or function. So we're going to go, what I'm going to do actually is I'm just going to copy this formula over here. And this is why named ranges become really important, because as you can see this formula is getting really long, and it's going to get harder and harder to read, especially if it's someone else doing this. So value 30, 0, I'm going to change the and to an or. So what this is going to do is anyone who's passed all subjects will get a $100 prize. If you haven't, it's going to ask the question, anyone left, have they passed at least 1, because we've used the or function. And if that's true, then they'll get $30, and if not, they'll get $0. So what we're going to see now is he's going to get 100 as we expected. all of these guys are going to get 30 because these guys, he has passed math, he's passed math and English. The only people who aren't going to get a prize are these two because none of their scores are greater than the average. So hopefully that made sense in terms of how do you nest a formula multiple times using logical functions. Now I'm just going to show you a couple of other things. So we've talked about and function, or function, and not function. I'm going to talk about the if error function as well. So let's go back to this example over here. So let's say we've got a large data set, and because automatically if the or function doesn't come up with an answer, what it's going to do is it's going to throw it into a 0. So if we have an error or something in there, it's not going to give us the result we wanted. So what we're going to do is a function called an if error to remove any unintended errors in the data which might be throwing at your function. So let's have a very simple example over here where we just want to find out the difference between two different dates over here. Now because the data isn't formatted in a certain way, what we're going to get is an error because we're trying to subtract a unknown format from a date format. So let's see what happens if I put the same date in the proper format. You can see the functions working. We just format that as a number so it's easy to read. So yep. So what we can do is we can protect against potential issues if someone's going in and pasting the data or our system comes out with funny values. What we can do is put in a little formula called an if error wrapped around our existing function. So the first thing is what the value is. So just leave your formula as it is like that. And then the second thing you have to do is what value do you want in there if you do get an error. Now you can do a few different things. You can put a 0 in there and that make the answer just show up as nil, because sometimes you might get a table of random numbers like so, random data set, and then for whatever reason we've got an error in here. We discussed some of the types of errors in the basic Excel training course, but let's say we've got a random error in here, div error. So even though it's just one cell that's an issue, Excel won't count anything. It's just going to show an error in the total bar. So what we can do to avoid situations like this is we can just wrap the individual cells like so. We can go if error and put it as a 0 so it doesn't mess up with the formula. Or alternatively, some people like to put in the value field it actually saying error so that people can actually see it and it stands out like so. And maybe even add in conditional formatting like so. So it really stands out to the reader if they can see that. So it's just a good way of getting around potential errors in your data. Also a logical test as well. So the first thing is, the logic is there an error? And if the answer is yes, then you put a value in. Now granted there's no false section, and if it's false, well then the formula is as it is currently. So whatever's in the calculation bit here in the value section. That we're going to be talking about is the true and false functions. So we talked about before about where in a logical function we could put a value if it was true or false. But what we didn't talk about is that you can actually use the words true and false by themselves and they actually mean something. So you'll note that normally when we're typing text that we have actually type in those with apostrophes like so, but with true and false you don't, and the reason is because Microsoft Excel actually assigns a value to true and false, and that value is 1 and 0. So let me show you what happens. So what I've done is I've just replaced the true and false values with just the words true and false, so no apostrophes or anything, which is unusual for text. So if I drag this down, so as you can see, wherever it said achieved, it now says true. So it's a bit of a faster way of having an outcome. And not only that, is you can actually assign a value to it. So for the false values, if I go equals false, but I can also go equals false times 25, and the value I'm going to get is 0. Now see what happens when I times true by 25. It's actually going to be 25 as well. And that's because this is a value. What if we do +1? So +2. So we can do things like that and integrate that into our formula. So for example, if we want to go, he's achieved his target, we want to give him a bonus of $25,000. So what we can do is integrate it into the formula, like so, times 25,000. See, and now when we drag it down, we're going to get zeros for false and 25,000 for true. So that's a good way of using the true and false functions to simplify your logical functions.